All right, before we took our break from recess, we were doing a couple things with some numbers. We were actually decomposing them, which means that we were breaking them apart into maybe two different numbers, but if we added those numbers together, it became that whole number again. So the samples that we made were just right over here. We didn't make very many to show, but you made a whole bunch in your math journal. So we took the whole number 10, and we could partition it into two different numbers, or we decided we could partition it into more than two, couldn't we?
Yeah.
All right. So we're going to take that now, and we're going to work on the next piece of our part. Now, earlier we talked about two mathematical practices that we were going to be working on. One of them is that we are going to persevere as we work through our math. And that means that if we start to do something and it doesn't make sense, what are we going to do? We're not going to ask a teacher, because I may not know either. What will we do, Carly?
We could try to work it out on our paper or think about it.
Right, you can think about it, and if it's not working the way you think, can you stop and try a different way? Absolutely. All right, the other one we're going to be working on is look for and make use of structure. And this is going to be really key in our lesson today. Our two learning goals, like we talked about earlier, is to use drawings. We took out the word equations because we're not really going to write equations this afternoon. But we want to use drawings and or math tools to solve math problems that involve finding equal parts. Then we'll also be using mathematical vocabulary such as unit fraction, decompose, number bond, rectangle, circle, halves, thirds, fourths, sixths, and eighths. Now, I've only put two of the words up here, but as you see, if there's an opportunity for us to add more, we'll go ahead and do that. Should I go ahead and write the unit fractions as well as some of the others I just mentioned? Would that be a good idea? Okay. So, we will be talking about unit fractions. We'll be using the term rectangle. Circle. And then we're going to really get into the parts that we would use when we're identifying fractions. Halves, thirds, fourths, sixths, and eighths. If I can spell those correctly. Now, if there's another word that we can put up here, you're more than welcome to come up and put that other word in there. You'll go ahead and open your math journal. We're going to work on a math problem. The math problem is going to be up in two spots to help you see it. And here's what it says. Mrs. Scherr went to a coffee shop before school. She spent 1/6 of her money on a coffee and 1/6 of her money on a bagel with cream cheese. How much of her money did Mrs. Scherr spend before school? And then your bonus. Did Mrs. Scherr spend more or less than half of her money? You'll start your solving in the next blank spot in your journal. Please. What are you thinking of, Sebastian?
But how much money does he have?
Okay, does that matter? Okay, so what can we do with the information that we've been given to help us come up with a solution that makes sense? Can I see what you're doing? I'm confused though. How are you coming up with 1/3 because it's talking about 1/6 and 1/6? Wait, a half and a 6 is 1/3? Oh, so when we folded the pieces into thirds, what do we do with the thirds to make them into 6? We folded them again, right? Interesting. Could you draw a picture to support your thinking? You have a lot of instruments that you could use. What are 2 things that you could use? Yep. I'm curious, why do you have pennies in here? Mhm. Okay. Now, how do you know that she spent less than half? Can you explain that in some way? Awesome. So how do you know that it's 2/6? Can you prove that with the drawing? You don't have anything on your paper. Let's get started. Remember, if you do answer the first question, you can work on the bonus. Okay, so how do I know how you partition these into 6s? Because I only see your little lines here. And then what does this no mean? Can you explain and elaborate for me just a little bit? Thank you. So can you explain why you think it's less? Thank you. But your question's asking me, did I spend less than half or did I spend more than half? I can't have both. It's going to be one or the other. What do you think? Think about it. Yes, what? Why do you think it's less than 1/2? Okay. So what do you mean by that? Can you draw a picture to show me? Okay, you're going to draw it. I'll come back in just a minute. So can you explain how you know that that's true? I'm going to give you about 30 more seconds, and then we're going to come together and talk about this. Sixth. Just a skinny rectangle, maybe?
No, just doing it circle.
Okay. Can you explain why you think that? Can I borrow this for us to discuss? Awesome, thank you. I'll give it back, I promise. Okay, so did you think about the bonus? Why do you think that? Scherr. We're going to discuss with them. Thank you. All right, if you go ahead and finish the one thought that you have, and what I'd like you to do for about a minute is turn to your partner and share with them what you developed in your answer, as well as if you were able to explain your reasoning with the bonus question. So would you come?
So Taylor, came up with I did. Could also be she spent $5 to $6. For $1 on coffee and $1 on bagels. And then I would put less than 1/2 of her money because 2 is not enough for 6.
And it looks like you're still thinking about your reasoning.
6 plus 12 equals 12. Mr. Scherr has $12. Mr. Scherr spent $12. $6 and then bonus. Yes. I think no, I don't think she had more than half of her money. More than half. It's just less. It's less.
We can come back together in 5,
Because 2's not enough.
3, 2, 1. All right, I'd like to take a minute and I'd like to show you 2 ways that someone came up with this. Let's see if we can get this a little clearer. Now, this student looks like they drew a picture here to represent the answer. What I'd like you to do right now is I'd like you to talk with your partner. Is this an accurate justification to the problem? If it is, why? If it's not, why not? Any questions? All right, begin. So what do you think?
When you were saying 2 the word 2, yeah, I just found that
No,
out.
I'm asking, is that a true representation to the answer? Okay, and why do you think that?
Then you have to make 2 more on the last one. So it can't be like what? I can't ask questions right now. It doesn't work. It can be like filming. It just doesn't work. I can see a lot of kind of. I'm confused.
All right, let's come back together in 5, 4, 3, 2, 1. If you have a straight edge in your hand, would you please put that on your desk? Thank you. All right, I need to know if someone agreed that this was a good representation mathematically for our answer. Elliot, what did you and your partner talk about?
I disagree because how would it be 1/3 when there's already 4 not shaded and the other 2 aren't?
Good question.
How is there? I'm just saying.
Okay, so you're questioning how can it be 1/3 when you have 4 that are unshaded, right?
Yeah.
Okay, can you look around the room? You have a lot of people in the room that think that they have an explanation for that. So if you would call on someone and that person's going to come up to the board and going to draw that out.
Well, I looked at it kind of like a times table, and 3 times 2 is 6, and 2 times 3 is 6, and
Wait, I need you to put it on the board. Can you write it on the board so you can explain it a little bit better?
well, since 3 times 2 is 6, and 2 times 3 is 6, that it kind of makes it so they're kind of equal, and so
Okay, wait, hold on. Let us think about what you're saying.
I kind of
You said 3 times 2 equals 6, and 2 times 3 equals 6.
Yeah, and well, there's 3 2s, 2, 2, and 2, and so that's why you said 1/3, because 1/3 is shaded in, and 4 isn't.
Interesting. We're going to let that sit for a minute. Thank you, Ryan. Ellie, can you call on someone else? Can someone think of a different way to explain this? Because I think I'm understanding what Ryan's saying, but I'm still a little confused.
Is it? So, I saw that, if you divide it into 6, that's so close. If you divide it into 6, then, and you shade 2 in, it's 2 6, but this could be, these 2 could be 1/3, these 2 could be 1/3, and these 2 could be 1/3. So this is 1/3, this is 1/3, and this is 1/3. So if you had just this one shaded in, that's also 2/3.
I'm somewhat seeing that. Someone have a different way to explain it as well. Because I'm starting to understand what Ryan is saying, where it's similar to multiplication. I see what Isabel's doing where she's putting them into thirds. Elliot, can you call on another person for me, please?
So like, basically, it's just, so you're just gonna draw 6. Once you draw 6, if you shade 2 in, and then you just erase the middle line, it makes it 1/3. So basically, you're splitting the 2 in half and the 6 in half, and then you're erasing the middle line.
Why, I'm curious, why did you erase the line?
Because
when you split it in half, the number in half, if you like. Because 2 of the 6.
So what's the relationship between thirds and sixths then? Talk to your neighbor about that for a minute. What's the relationship? Watch this. What's the relationship between thirds and
if you split a third in half, you get a sixth. And then take away these ones. That one. I don't get that. That's serving. I think I still don't serve. I kind of get it. I agree. That cleared up. A little bit, but I still don't. With thirds, you can just divide them in like half of each third.
Let's come back together in 3, 2, 1. So boys and girls, I'm still hearing Elliot. And Elliot is saying, I still don't understand this. And last week when we were doing something similar to this, where a person was up and explaining their thinking with math, it wasn't making sense to even me. And you all had to have 4 or 5 different people come up and show different ways of looking at something. And then I finally got it. It finally, all the puzzle pieces came together. So Jenna, would you go up and explain just a little bit? And Elliot, keep watching, because you may see that something is going to be there that you're going to go, oh, I see it now.
So if you make thirds, and shaded 1, and then you split thirds in half, it would be 6, and 2 sixths would equal 1/3.
So Elliot, what question do you have for Jenna?
I think I kind of get it now.
Okay, so can you re-explain what she just said? And you can go up to the board if you need to. And Jenna, you stay up there in case he's got a question.
So if we do a line here, then it would be 6. And then if you erase that line, then it would be 1/3.
Okay, starting to make some sense for some people. All right, Nick, can you go up? Thank you, Jenna. Thank you, Elliot. Nick, can you show us one more way to think about this?
I was thinking about grouping. Because there's 3 there's 3. If you add 1 3 times, you would get 3, and if you add 2 3 times, you would get 6.
Wait, say that again?
If you add 1 together 3 times, it'd be 3, and if you add 2 together 3 times, it'd be 6.
Okay.
So this is what. That's the way I'm thinking about it. Oh yeah, I see it. Because there are 2. It's like 2 squares are in one of those.
That makes much more sense.
They're still divided into thirds. But you're dividing it like half.
Because 1 plus 2 equals 3. 1 plus 3 equals 3. And then 1 plus 2 equals 3. So 3 plus 3 equals 3.
Okay. So I am now very confused. How many of you are very confused? I was starting to understand what was happening here when Jenna came up and Frankie came up and Isabel came up. And now Nick is giving us, it's not to say that it's wrong. I just don't understand it. So, I need some help with the explanation. So, Sky, can you go up and help Nick? Because what Nick explained was perfect. However, I'm a slow learner and I need somebody else to kind of say it in some different words.
So what he was saying was 3 2 times equals 6, and 2 like 6 times or just times 6 times 2 equals 12.
I think you mean to be doing that at the bottom one.
Yeah.
Okay.
Yeah. No, I'm really
I didn't
confused.
say anything with 12. 3 times 2.
Okay, now stop for just a minute, Sky. Where are you getting the 3?
From up here.
The 3 groups.
Yeah.
The circles, right? So the 3 circles, which we're calling the 3 groups. And where are you getting the 2 from?
There's. Yeah, 2 in each group.
So that's why we have our tally marks of the 2 in each of the groups. Okay? I see that one, but now I'm confused about the top one. So what would you do, Sky, with the top one? Can you take the same thought, thinking? No?
But you can also think about the relationship between the 3 and the 6, because 3 plus 3 equals 6.
And why is that important to know that 3 plus 3 equals 6?
So you can kind of understand why it's kind of hard to explain because
I'm not sure how to explain it.
I know, it's very, when we start to think mathematically, it's really hard to put it into words. So Amelia, can you also go up? Because, again, these are really interesting thoughts with math, and we need to make sure we're understanding.
Gaia with this one, but but with this one, you see there's 3 groups, and it's like on these. There's 1, 2, 3. And then, so it's kind of like that, and then there's no, and then it shows 1, 1, and 1. So that one would be like, there's 1, 1, 1, and 1, and then if this was a rectangle, it'd be like this. One, and 1. And then you get this one. So I'm going to use the same rectangle, and then there's going to be 2, 2, 2, and 2.
So you're partitioning the thirds into half, you're partitioning the thirds in half, which then makes it into what?
6.
6. Okay? All right. There's one more piece that I think that we're not seeing. You 3 may go ahead and have a seat because we're getting too many up there. Thank you. We're going to continue with what Nick is saying, though. Mia, can you go up and see if you can put a little more, shed a little more light to it?
So you get 3 times 2 equals 6.
Right, but that's what we said down below.
Never mind. Evan. Yeah, I think because he did it. You know what you do.
Oh, this is Kevin's problem?
No.
This is Kevin's solution up here? It is. But remember, we were talking about how it wasn't, we were challenged with understanding that 1/3 is the same as 2/6. So, Kevin, can you go up and explain? And I'm thinking that we can connect it. If not, I'm going to show you one more thing.
That's going to be my ruler. So this is 2 inches, and this is what I'll make. So this is what I think Nick is thinking, because this is half of that, and split. That would be the same.
Did you see what he just did?
Wow.
What did he just do with those top numbers?
Amazing.
He just took his finger and split them into twos.
Banana split.
And you see, if I measure it, this is 1 inch, and that's 1 inch.
Why is that important?
I don't get this.
Equal.
Why does it need to be equal?
Why does it need to be 1 inch?
Okay.
It's not a fraction.
So,
It's equal.
when we are talking about fractions, it's not a fractional piece if the pieces are not equal, correct? Okay. Now, thank you, Kevin. There was one more, thank you very much. There was one more piece that I was going to do to this, but everyone was doing such a good job of explaining it. What happens if I shade this in, and I'm just going to exit right now, because does everybody agree that I spent 2/6 of my money?
Yeah.
Because I spent 1/6 on coffee, right, Brandon? And Sebastian, what did I spend on my bagel with cream cheese?
1/6.
1/6. And 1/6 and 1/6 together make 2/6. So have I shaded in how much I've spent? So if you're saying that these are the same, and this is the same, and this is the same, I've just split them and given them 2 in each of the groups. This shaded, is that also representing the same as this one?
They're exactly equal.
Okay. All right. So the question then becomes, is this then a correct justification?
Yes.
Okay. Hold on, I have one more.
No, it's not.
Okay. Hold on. Remember, we want to look at the math. I want you to talk to your partner for just a minute. Is this a correct justification to the problem? Because I do see 2/6. But I also want you to take a look at the actual, what do we call this with our drawing? Is this drawing really representing the 2/6? And if it is, why? And if it isn't, why not? Okay? You have about 30 seconds to talk to your neighbor. Go. What do you think? Is this showing 2/6?
Wait, 1/6 plus 1/6 does not equal 2/6. I got it. Yeah, it does. No, it doesn't. Yeah, it does. No, it doesn't. Then what does it equal? I don't know. My brother probably knows. Then why are you disagreeing? If you don't even know what it is. Then what is it? It's not 1/6. Yeah, it's 2/6. It's this OP. Why? OP. Elliot, all you have to do is add the ones. You know what 1 plus 1 is.
2, 1.
I disagree so bad.
Thank you. Will, can you explain what you were just sharing with me with this justification?
If you add the bagel and the coffee,
Okay, wait, but you said something. What is this representing?
a bagel,
And what's this representing?
coffee.
I didn't realize that. Okay? How many of you knew that this was a picture of the coffee and this was a picture of the bagel? I was honestly thinking that this was supposed to be representing 1/6. And I struggled with that. Because is this representing 1/6? No. It's really just a picture of a coffee cup, isn't it? And here is our representation of how much it cost. Okay? All right, so continue, Will. So,
If you add the coffee mug and the bagel, and then you split them in half, that makes 2/6.
what do you mean if you split them in half?
If you have a coffee and a bagel, then we would plus them, split them in half, and then split them in again until you make 6. And then you shaded 2 and write 6. It's really hard to explain.
Right. I see what you're saying where you're trying to split the coffee, but I'm actually going to drink a whole cup of coffee and I'm going to eat the whole bagel that they gave me. So it's really more about the money. All right? Hold on. Stay up there, Will, for just a minute. Someone said they had a question. Nick?
For whoever did this, I'm wondering where the other 4/6 is.
What do you mean?
Because it looks like there's one half right there and one half right there. I'm wondering where
With
the
the
other
picture, you mean?
Yeah.
Mm-hmm.
Because I'm not sure where the other 4/6 is.
Well, I'm not sure if this person actually was thinking of drawing a picture to show the money part in 6. I think that they drew a picture of the coffee and the bagel, and we're making an equation. Do you see an equation in here? Right, because earlier in the day, we had talked about our learning goal having an equation in it, and I think that's what this person did. Okay, Carly?
What I was thinking.
Well, what I'd like to do is go ahead and move on because I've got some more things for us to do mathematically. And I think that we're all starting to see that the representation of 1/6 and 1/6 is equal to 2/6. Is that correct? Now, the question now becomes, thank you, Will. Kevin?
I still have a question because about the 1/6 for the coffee and 1/6 for the donut. It's really confusing. At first, I thought Mrs. Scherr drank 1/6 of the coffee and ate 1/6 of the donut. But what does that have anything to do with money?
Right, because we need to go back to the question. And the question was asking, I think it was asking how much of my money did I spend? Is that right?
Yeah.
So we're not really concerned with what I drank and what I ate, other than those were the things that I bought. But now let's go to this next question. Did Mrs. Scherr spend more or less than half of her money? Okay, so here's my question. Raise your hand if you said that it was more. Okay, raise your hand if you said that it was less. All right, so I think we're all in agreement. Let's see. Ariel, what were you thinking? Why did you think that it was less? Okay, I didn't hear you. I'm sorry. Let me come closer. What did you think?
So it is not half of 6, so it's not.
Can I borrow your book for a second? You're very soft-spoken, and I can hear you have something that everybody should look at. All right, let's look at what she wrote. Okay, and she used words to explain. And she put in here, Mrs. Scherr spent less than half because 2 is not half of 6. 3 is half of 6. I want you to take a minute and talk to your neighbor about what you think about that. Correct?
Yeah, and it's hard to explain that. It's hard to because 6 divided by half is 3. Half? What's half though? Half is H-A-L-F. You mean divide it in half. What's dividing, Bill? I'm not sure. What's I'm not sure? What does I'm not sure mean?
All right, let's come back together.
I'm not sure.
In 3,
What does that mean?
2, 1.
You.
All right, Carson, what did you and your partners talk about?
We said it looks good, and that she's right on this question because in fractions, the bigger the number, the smaller the fraction.
Wait, what? The bigger the number?
The smaller the fraction.
Are we back to that one?
Yeah, I said that a long time ago. Then
I know.
what does that have to do with this? What does that have to do
Okay,
with
then hold on. Wait just a minute. Let's not all start sitting there and attacking, because remember, we want to use our accountable talk. We want to think about the math. What does the fact, Carson, of what you just said, why does that matter to this?
Well, because she put Mrs. Scherr spent less than half because 2 is not half of 6. 3 is half of 6. It's 3. 6 is. It's hard to explain. 6 is like more. I cannot explain it.
I would agree 6 is more than 3 and 6 is
Yeah.
more than 2.
But in fractions.
But in fractions,
But in fractions, the bigger the number, the smaller the fraction. So it is less than half. Oh my gosh.
okay, wait, say that one again. Everybody needs, I don't have everybody with me.
Wait, what part?
Josh, you need to sit up. Phoenix, you need to be listening. And now I lost what you just said.
Me too.
So, who can tell me what he just said? Because I just lost it. What did he just say, Nick?
Bigger I'm not sure what he said.
It was something with the bigger the fraction, the smaller the pieces. But there was something with 3 and 2 that you were saying. I know.
Was it 6 was bigger than 3 and 2?
It could be that, yeah, 6 was bigger than 3 and 2, right?
But in fractions, it's smaller.
Right, but in fractions it's smaller.
And the 2 is
In fractions, the 3 and the 2 are bigger.
Okay, wait, hold on. 3 and 2 are bigger parts of the piece, of the whole,
Yeah, in fractions.
in fractions. That is correct.
What we're talking about right now is not unit fractions. It's still the 2. It's 2. The numerator is 2, not 1. So it's not a unit fraction.
It isn't a unit fraction, but at first we did have to take our rectangular shape or our circle shape, and we did have to partition it into 6, didn't we? We did. And then from that, when we partitioned in 6, did we use unit fractions to partition it? We did. So we started with the unit fraction and then we built up to 2 6, correct? Okay. So I believe that we all agree. I think Ariel has an interesting point with the fact that she's already proved that half of 6 is 3 and 2 is not 3. All right, we're going to move on because I have one more thing I'm going to share with you. Okay, the next one is, earlier in the day we had talked about number bonds. And Matthias said something shocking to me earlier. And when we were doing number bonds is where we take a whole number and we break it into parts. And I believe what we were talking about was we were taking the number 3. And I think I had said that there was no way that you could take the number 3 and use more than 3 of these here.
You can.
And Matthias corrected me. Matthias, can you tell us again what you said?
So you actually can, because if you make fractions, so like if you made them all be halves, then you'd have 6 lines.
So instead of using whole numbers for my parts, if I used fraction numbers, could I have more than 3 circles?
Yes.
I could. All right, we're gonna try that right now. In your journal, can you go to your next blank spot? And I'm gonna ask you, I'm gonna be pretty quick. I'm gonna ask you to decompose 4 into ones. Go.
Oh, that's easy.
Okay? And we'll see you tomorrow.
I know, you just do one. Or is it 3 and 4? I thought it was 3 and 4 and 5.
All right, everybody now should have the number bond in their journal. You don't have anything in there, Brandon. So Colin, how many circles did you have below the 4?
You could have 4.
I'd have to have 4, correct? Why, Colin?
We had to put it into, wait, I forgot.
Because we had to do what? What were the directions?
Wait, I forgot.
To decompose 4 into ones, right?
Yeah.
So this would have to have what in it?
1.
What about this one?
1.
And this one?
1.
And this one? Okay. Now, what would happen if I wanted to show 4, but I wanted to decompose it where there was a 1 and a 3? Can you show me that in your journal? I need you to push in your chair, sit up,
1 to 4.
and follow what we're doing.
Oh yeah, that's
So you're going to decompose 4, one of which is composed. Oh wait, what did I say? I think I said this wrong.
4 into 3, 1.
I did. I think I told you the answer there.
Yeah.
Okay. That probably wasn't what I was supposed to do. All right, so if we did that, what would go in each of these?
3 or 1.
3 or 1, or I could have reversed them, correct?
Yes.
Okay.
Or you would put 2 and 2.
I couldn't put 2 and 2 because I said in your decomposing you had to have 3 and 1. And 2 would not work because that is not the same as 3 and 1. All right. All right, let's go ahead and go to our next problem.
I thought you said next blank page.
If I'm looking at these two solutions, I need everybody to look up here so you hear my question. How many bonds did it take to decompose 4 in this one? 4. It took 4, didn't it? How many bonds did it take to form this one? 2. Okay. Here's your next problem that you're going to be doing in your journal. Ready? You're going to decompose 1 into fourths. Let me say it again. Decomposing 1 into fourths.
Are we allowed to use decimals?
No, you may not use decimals.
Use fractions.
Think about what the T has told us.
Done.
What does the term fourths mean? When you hear the term fourth, what do you know?
It's not. You need to do fractions. We've been doing for the last 2 months. Fractions.
You can't? Watch me.
Watch
Watch me.
One is like watch me do this.
I just did that. I took 1 and I split them into fourths. No, it's not. What would go in here?
It's confusing. I didn't get it at first.
All right. Josh K. What am I going to put in each one of these? I'm going to put 1/4, 1/4, 1/4, and 1/4. And when Matthias said, earlier when we were talking about the threes, before we started this part of the lesson, and I said, well, there's no other way you can do it. It only can be 3 parts to the number bonds. He said, oh no, Mrs. Scherr, you can use fractions. And then what did I say? I said,
Correct.
that's right. These are whole numbers. These are fractions. Can we still decompose fractions?
Yes.
We can. Is it going to be harder for us?
Yes.
It is.
Really?
It's going to be really hard. So let's come back to this one. If you don't already have this in your journal, please write it.
25. So like 1/4 is like a quarter, and then the 1 is like the dollar. So quarter.
Now work with your partner. Hold on, I'm not done. I want you to work with your partner, and I'd like you to take, make sure I say this correctly. I want you to show a number bond decomposing 1 into 2 parts, one part of which is composed of 3 copies of the unit fraction.
What?
3, 4.
I don't get it.
Okay, stop. Okay, I want you to stop talking, and I want you to listen. Because remember, sometimes when I say something, if you're just sitting there going, what? What? Are you really going to be thinking?
No.
Okay, so listen again. Thank you. Now work with your partner to show a number bond decomposing 1 into 2 parts, one part of which is composed of 3 copies of the unit fraction. I need you to take that off. Okay, so you guys should be talking. What's a unit fraction? What are 3 copies of a unit fraction? What does that mean?
She said 3 copies of a unit fraction.
Did you just hear?
Okay, 1/2 and 1/2. 1/2 and 1/2.
I don't get it.
I said 1/2 and 1. I did it!
I don't get it.
Okay, so what are we coming up with over here?
You're not listening.
It's got to be 3. I said 3 copies of the unit fraction.
Wait.
What's a unit fraction?
Oh yeah. Okay, stop. Okay, stop. Elliot, just stop.
That's for you to figure it out.
Yeah, but you said
Okay.
copies of the unit.
Megan, would you please go up and draw that up on the board for me, please?
You drew it. There's only one way to do it.
If you'll take a minute, I want you to watch Megan, and then Megan is going to describe what she's actually, how she was thinking this. All right, how did you, or why did you put 3/4 on one of the parts of the number bond and 1/4 on the other part?
Because 3 is a copy of 1/4. 3/4 is a copy.
Wait, I'm sorry, not everybody's listening.
3/4 is 3 copies of 1/4, which is the unit fraction.
Wait, you just said something interesting. 3/4 is 3 copies of 1/4. And what is 1/4?
1/4 of the whole.
Right, it's a 1/4 of the whole. Is it a unit fraction?
Yes.
Right, because let me read the directions again and look at her solution. Show a number bond decomposing 1 into 2 parts, one part of which is composed of 3 copies of the unit fraction. Do you see the connection with those? Okay. So what are the 2 parts of our number bond? Amelia, what are they?
3/4 and 1/4.
3/4 and 1/4. And when I put those two together, what does that make?
1/4.
It makes one whole, doesn't it? Okay, thank you, Megan. You can have a seat. All right. So now we're going to have to stop because our time is up. Here's what we're gonna do. I know it went by really fast, didn't it? I need you to listen though. Everybody needs to put their eyes on me. Excuse me.